Okay, so yeah, it is unmuted. Okay, I'll just so last time we were talking about the virtual standard switch, and we talked about vSS, and we talked about different features of the virtual standard switch. Also, let's try to. So we talked about. Well, I'll just we'll go through that as well. But port groups and we created port groups there. We attached detached virtual machines to and from port groups in one virtual standard switch. Added, removed, added and removed the physical, actually not removed, but added physical NICs, and other than that, we also explored features of virtual standard switch. Also, we explored the features of the port group, which are pretty much similar to virtual standard switch with the override option there. So for our typical port group, what are the features of port group in a switch? V-switch, we can say. Normally, we have an override option. Override option for each feature being inherited from vSwitch. So we've gone through all that, but what we did not do was so we need to now, so today we need to create multiple virtual standard switches just to explore the features of a switch. So we need to create multiple VSS, just how different it is, and how many standard switches. Well, just the creation process, what features are inside. If we have multiple switches, why would we want to create multiple switches? So just that, and then we need to go for let's discuss and explore Vmotion. So we need to do that, and once we're done with that, then let's discuss and explore distributed switch, distributed virtual switch, and then finally we will go for let's create cluster, and loads of features after that are coming. So let's carry on with our virtual standard switch, where we have gone through different components and features of one virtual standard switch, but we haven't created multiple switches, so that was remaining there, and then we go on. So I'm gonna go back and check my machines there if they're on, and since I unsuspended it, so I'll just close this. So it's going to ask me to sign out, sign in again, and so it's already signed out. I'll click advanced and proceed to VCSA. So we're from Windows machine we are remotely connected to. our virtual machine VCSA here, and administrator at vsphere.local. So let me see, let me see shift 0.23 without shift 0.23. Okay, so once we're inside, I'll just make it full screen here, and my hypervisors, both hypervisors are up. So TorDC has E6i1, E6i2 showing there, while NYDC has E6i3 showing there. Inside the E6i1, my VCSA is there, and the E6i2 has a VApp and resource pool created, plus a lot of virtual machines showing there. So on E6i2, it is already selected. And this is what we were discussing. We were just connected to E6i2, and there we were just exploring the virtual standard switches. Now, virtual switches, so I'm on E6i2, then I go to the right side of it and click the configure, and from there there's a storage, there's networking, so I'm actually going to the under the networking is virtual switches, and in the virtual switches I'm in that virtual switch. If I just show up here, so it's vSwitch 0, and inside the vSwitch 0, so we have talked last time that this is the virtual switch. So on the right side is the physical side, and the left side are the software side of it, and we create multiple port groups here, and detached virtual machines there. Then we went inside port group, went inside the virtual standard switch settings. So but we need to create multiple virtual standard switch. It's not like we need to, but we should. So we could just explore what are the, first of all, why should we create multiple standard switches, and then okay, so I'll grab this diagram here, and so here between 0 1, so our VCSA is obviously on the RAM of E6i01 here all the time. It is there, and obviously we need it. So VCSA7, and its virtual disk is here. Yep. There's no question. So guys, please do mute your mic, and thank you. Okay, so here we disk, and this is VCSA, this is VM. So that's how our VCSA is working. It's on maybe LUN 0, LUN 2, or LUN 1, but it is on a LUN based data store. And so yeah, we were talking about the standard switches, and we're on E6i2 right now, where we were just exploring the virtual standard switch that we have already. And how about if we want to create multiple switches? So right now the configuration is that on E6i2 we attached a second NIC to the virtual standard switch. Hold on. And so there are two phi NICs there, physical NICs there, that have been attached to the virtual standard switch. But we've explored the features here, but what if we want to create multiple standard switches And why would we want to do that? So suppose there are two more standard switches that we want to create, and the simple reason would be so this is normally, if I just go back to my environment, so the naming is vSwitch 0, and that's the naming. We cannot change the name of the switches. So if you create second and third switches, so they would be just added vSwitch 0, vSwitch 1, vSwitch 2. So the naming is like that. So vSwitch 0, and then we would create vSwitch 1, but again the question is why. What situation you would want multiple standard switches. If you have 20 virtual machines, you can just simply connect to one standard switch and it would be working fine. Technically it's okay. Technically you can do this, but the reason that we would want extra virtual switches would be, suppose there are virtual machines here, and we're talking about virtual machines that are on top of ESXi 2. So suppose there are lots of virtual machines on ESXi 2, and it's not that only that there are lots of virtual machines, but some virtual machines are really bandwidth heavy, so they consume a lot of bandwidth. So in that case, it's going to be it's going to be a lot of pressure on the one virtual switch that is connected to the two physical NICs there. So that's why if we have multiple standard switches, so how do we regulate that traffic? How it is really helping in the bandwidth? So it is helping in the bandwidth because suppose this is a SQL machine here, and that's sending huge amount of data, and there are databases inside. Suppose there are multiple SQL servers there, Microsoft or Oracle SQL servers. So that's a lot of in and out traffic going on there, but that all traffic is actually going from the virtual machines to only this switch, and through that switch it is going through those network cards here. So these two network cards have the pressure of not only those SQL servers, but the 10 other, suppose there are 10 other virtual machines, total 13 VMs, suppose. So in that case, you would see, obviously you would go for monitoring software and check that, or if you had received a lot of complaints that there's a file server here as well, and that file server, when the users are connecting, it's too slow, but the performance is really degraded there overall, or just the traffic is, packets are dropping, and when I send data, it's just not reaching there. So you then try to diagnose, and you see that a lot of bandwidth is being used, and these two network cards are overwhelmed by the amount of in and out traffic here. So in that case, you would go for extra network cards. So that's why we did add total 10 network cards, and it is recommended to have more physical NICs in each physical host on top of which you have a hypervisor. So you would create the second vSwitch 1, so it will be vSwitch 1 because the counting starts from vSwitch 0, and that will be connected to its own two network cards. And then so that's the vendor best practice, or anywhere best practice is this, that if you could provide more physical devices for any kind of situation where you have a lot of traffic, a lot of memory, CPU consumption, you just add processors or add memory. So just like that, you add standard switches that are connected. Each standard switch minimum is connected to, if possible in a production environment, is supposed to be connected to a minimum 2 physical network cards. Now again, why did we create that? So we know that the virtual machines see port groups. They don't directly see a virtual standard switch. So obviously when you want to connect a virtual machine to a standard switch, other than, so vSwitch 0, we had 3 port groups created last class. So those 3 port groups, PGs, are to which all the machines are connected. Now, obviously, when you create a vSwitch1, vSwitch2, you would simply create their own port groups. So PG1, vSwitch1, VS1. So you would just go for that port group, and you have to have, when you create a standard switch, a port group is a mandatory. It gets created with a switch, right? So we're about to create virtual standard switch 1, virtual standard switch 2, just to explore the whole process. So virtual machines now will start seeing, once you have created virtual standard switch 1 and virtual standard 2, they will start seeing more port groups because they can only see port groups. So virtual machines network cards will be, what we can do is we can simply disconnect the standard switch, or that we can also say switch the network adapters. They were connected, SQL Server suppose was connected to the port group of vSwitch1, which was 0, sorry. So it would be, we can just reconnect it to, or switch from vSwitch 0 port group to vSwitch1 port group. So now at least the bandwidth side will be covered, that SQL Server machine traffic should not be going through virtual switch 1.0. Suppose file servers, there are multiple file servers here that are on this particular host, and those enough are having a lot of traffic during peak hours there. So you would just connect all the file servers to vSwitch 0, while you connect the 2 SQL servers that are sending and receiving traffic, as much as 5 or 6 file servers are doing that. So you just move away the SQL Server virtual machines network connection from the port group of vSwitch 0 to the port group of vSwitch 1. And if there are other machines or group of machines that suppose there are web servers, 3 web servers, 5 file servers, 2 or 3 SQL servers. So those web servers, you could just create one more standard switch. And now you would want to create more standard switches when you are able to arrange more network cards there. So the whole traffic flow can be then maintained, that okay, so these machines, 3 machines of web servers can be connected to the port group of vSwitch 2, which is having its own 2 network cards. So the traffic, or at least there will be no overwhelming traffic, or bandwidth would not be taking over by one set of machines and will not be available to the other virtual machines. The bandwidth will be then available, or enough bandwidth will be available when you have divided the network flow of the virtual machines through different virtual standard switches instead of one. Now we right now have 3 port groups here, 3 PGs, 1 VM kernel port, and 3 port groups here, right? So, but when we are creating virtual machines, obviously they are still hitting these 2 network cards. So the whole pressure is on these 2 network cards. That's what we are trying to divide. So the 2 network cards, the traffic that they were taking from suppose 13 virtual machines, after we're done with this, after we are done creating vSwitch 1, vSwitch 2, so the traffic will be divided between 6 network cards now. So that's the whole plan. Other benefit is that not only that the traffic is divided among physical network cards, the other thing is that the traffic flow can be also maintained. Suppose these are the 3 set of virtual machines, and they are connected to a virtual switch 2, and virtual switch 2 is sending traffic here to these network cards, and these network cards outside may be totally connecting to a separate physical switch here. So the whole traffic flow, while staying in one physical server, all 13 virtual machines, their traffic flow can be totally maintained as separate traffic flow, and suppose this virtual switch 1 is connected to another physical switch, and that physical switch is going somewhere else and it's not connected to this physical switch here. So the whole traffic flow can be separated with the help of multiple standard switches, because they're connected to their own respective physical NICs, and the physical NICs are connected to their own separate physical switches, which are actually even outside the physical environment. They are connected and taking the traffic on different directions. So while virtual machines are staying inside one physical server, their traffic flow can be totally separated from inside the virtual environment to outside physical environment as well. So what we can do is we can just now go ahead and create vSwitch1. While we have vSwitch 0, we're going to create vSwitch 1, and we're going to see that what kind of options are there, what kind of features are there when we create extra switches there. So we know now we know the reason. vSwitch 1 we're creating just to have some of that traffic flow burden sent away from these two physical NICs to these two as well, and then you keep on creating, and you're just simply dividing the traffic of virtual machines among different physical network cards, provided that you have physical network cards, enough physical network cards to go for these kind of vendor best practices for regulating the traffic, dividing and regulating the traffic to keep it fast during peak hours. So that would be the purpose of creating virtual switch standard switch. Suppose there are just few machines there, then you don't need to create multiple standard switches. Yes, there is another configuration. Obviously, you can do attach the instead of 2, you can just make 4 network cards here, right? So instead of attaching 2, you can attach 4 or 6 network cards to the same switch. So the same virtual switch 0 is sending traffic to actually 4 NICs instead of 2 or 6 NICs or 7 NICs or 8 NICs, doesn't matter, right? So you want to stick it through one vSwitch 0, or you want to put it and divide it among different virtual switches, standard switches. This is also what you can do as well. So there are many choices how you want to regulate the traffic within one physical hypervisor. Okay, so if I go back here, so we're inside the environment here, and we have already gone to add port groups, then an extra physical adapter, and so we're going to click this add networking again to check that can we create an extra vSwitch now. So vSwitch 0 by default is there, but can we create extra switches there? There's an arrow here as well, this one, and that just takes out the whole diagram. When I click that, when I click it back, so it just shows the diagram of, or the configuration of this vSwitch 0 only. Okay, now let's click add networking here, and once we click add networking here, so you can see Vm Kernel Adapter. Yes, we're going to be using that for an upcoming feature now, Vsphere V Motion, but right now we don't need it. So we need to go for, it says here virtual machine port group for a standard switch. Now it does not mention, actually we're going to go for this option, but it does not mention that you can create a separate, or you can create a new standard switch. It does not say that, but that's where the option for creating a new standard switch is. Obviously, when you create a new standard switch, you have to create a port group. One port group is mandatory when you create a standard switch. So that's why they're saying, hey, you want to create a port group? Yeah. So in the process, we can create a new standard switch and attach that port group, or use a port group of that new standard switch. So I'm going to select this second one and click next. So that's where it's saying vSwitch 0, you want to still create a new port group in the existing switch. This time we're going to go for new standard switch, and the new standard switch here, once we click the new standard switch, so it's just saying the maximum transmission unit, MTU. Do you want to keep it the same default as for all the standard switches there? So yes, well, unless you have a good reason to change it, it's okay to have those packet sizes packets taking this much bytes of payload there. Payload just means that data inside. So normally it's supposed to be same, unless you have a good reason to change it. So I'm going to select the new standard switch and click next. So since we have lots of adapters there, so we're just gonna give it a pair of adapters for this standard switch, minimum 2. I'm gonna click plus sign here, which is the green one, and we got a long list of adapters, so that's very good. The more adapters the better. So 2 are given here and press OK. So new standard switch having its 2 network adapters selected, and both will be used, so it will be doing load balancing. If you put one under standby, so it will be then failover, but load balancing is better. So click next. Now it says that what is the network label of the port group that gets created. Obviously it's mandatory to have a port group, otherwise how can virtual machine connect to a virtual standard switch? They have to have a port group. Now this port group we're creating, so we can just give it as simple naming convention as possible. So this is PG1 VS1, so the naming could be as simple as this, PG1-VS1 or without dash, however you want to go. So that would be port group 1 of vSwitch 1. So it's not port group of vSwitch 0, it's of vSwitch 1. The naming convention really saves a huge amount of time later when the environment grows and grows and becomes bigger and bigger. So, and VLAN ID, as if you want the traffic to be separate or it should be given a specific VLAN ID, then we go for that. So PG1 VS1 for the new standard switch. I'm going to click next here. And then I'm going to click finish. And recent tasks here says already complete. Yes. Okay, so there was a. So now above is vSwitch 0 and below is vSwitch 1, and it said here update network configuration. So if above I don't want to see that now, so I'm gonna just collapse the whole vSwitch 0, and now I see vSwitch 1. So if I want to then expand the vSwitch 1, so it's pretty much the same story now. Well, there's a difference here as well. The difference is that when we first saw the vSwitch 0, minimum there were 2 ports or port groups created there. One is the Vm kernel port, and the other one is a port group for virtual machines. There were minimum 2 there with the vSwitch 0. Obviously the Vm kernel port was related to the remote connectivity. Without that Vm kernel, so if I expand that now, so management network Vm Kernel Adapter or Vm Kernel port is by default created there because we need it. And we need it for what? To be able to remotely connect to this hypervisor and manage it. For remote connectivity and management, we need it. So by default, when ESXi gets installed, obviously one Vm kernel port with management network functionality gets created with the default virtual standard switch. So okay, that was for the first one. Do we need it for every standard switch that we create on this same hypervisor? No, we don't. We don't need a remote connectivity and management Vm kernel port added to every new standard switch. For the first one, yes, we needed that. I'm going to collapse this now. So what you see here is just a port group for virtual machines. So any next virtual standard switches will not have a Vm kernel port called management network. Can we create one? Yes, we can, but by default it does not get created for next standard switches. So, but obviously the standard switch is there for virtual machines to get connected. So the port group, at least one port group, is a must. So you can see that with vendor best practices configured, so you have 2 physical adapters here and 1 port group. That is minimum we need. This is how a second standard switch is created, and well, I'll just go for another one. So if I click the add networking here, and I'm just going to do the same thing with this second switch, which will be third switch, sorry. So virtual machine port group for the standard switch. I'm just going to click next. We just for the creation, we can create the same way again, otherwise we don't need it. Next, and I'll just add 2 more network adapters. Actually, we're running out of it and we need them. So after creating that and discussion about that, we need to actually get rid of those extra standard switches as well. So just the same process that we before, I just added the 2 network cards, and then it would be PG2-VS1. It's still vSwitch1, but port group 2 now. So that's next. So PG2-VS1, finish. So recent tasks is good, and yep, vSwitch2. So if I just collapse this, vSwitch1, so there's that vSwitch0, vSwitch1, vSwitch2. Okay, so vSwitch0, vSwitch1, vSwitch2, and other than what we discussed, so the best practices and division of all the traffic. Now what we can do is we can just detach one virtual machine from vSwitch0 and connect to vSwitch1, and one extra other virtual machine from vSwitch0 and attach it to vSwitch2, just to make sure that we do that final thing as well. So now all the virtual machines are actually connected to the port groups of vSwitch0. Now we should be able to see the port group of oh, did I put the wrong name of the port group? Yes, which was VS2, not VS1. So this port group name is wrong. This is PG1 of VS2. So if I had created a second port group on vSwitch1, then this name would have been there. This is PG1 VS2, and so I'm just gonna click this 3 dots here. I need to change this name of a port group. This is really misrepresenting the current configuration. So I'm gonna click edit settings here for the port group of the vSwitch2 here, and just simply changing the name. This is still the PG1 because it's the first, and for vSwitch2, so it's the port group 1 of virtual switch 2. So I'm gonna press OK here, and now our port groups are okay. So port group 1 of virtual switch 2, if I expand that, port group 1 of if I expand and go to vSwitch1, so port group 1 of vSwitch1. Okay, so I just put that naming convention here. Otherwise I should have put that for vSwitch0 as well. If I expand the vSwitch0, it has different naming convention. So if I keep going down, all the switches are expanded, and I can keep going down and see port groups and network card settings and everything. Okay, so I'm going to collapse vSwitch0 and collapse vSwitch1 and collapse also vSwitch2. So I just need to detach and attach virtual machines to different switches. It's just switching from one port group to another for a virtual machine. That's it. So I'm going for any next virtual machine. So VM01 imported. I'll click that, and then right click it and go to its edit its settings here, edit settings, and then to the network adapter, this one. So now the new port groups should be showing there as well. So if I simply click browse in the network adapter of one virtual machine here. Now we can see the other port groups here as well. So PG1, VS1, suppose this machine goes to the virtual standard switch 1. So I'm just going to press OK. So that's all there is to it, that you can just go for virtual machine network settings by going to edit settings of virtual machine and then drop down to network adapter settings and click browse and connect this to PG1 VS2. So now one virtual machine got connected to virtual standard switch 1 and the other one got connected to virtual standard switch 2. There's one more scenario, and that is, well, what am I? Okay, so one more scenario is this virtual machine. What if this virtual machine needs to connect to two standard switches? So this virtual machine is connecting to the standard switch VS2, and this same virtual machine needs to connect to standard switch here as well. Now, well, that could be a scenario where you have two set of network cards and they are actually connected to different physical switches which are going somewhere else. So these are, suppose this is subnet, a different subnet, and this is a different subnet, and the same virtual machine is supposed to be connected to two separate standard switches. So any of those scenarios where you want that, or suppose just for high availability of traffic, that this virtual machine is connected to this standard switch, which is going to the separate set of network cards, but it is basically connected to the same physical switch outside. And here also, or for redundancy, this is connected to the physical switch separate, and this is connected to another physical switch. That why? Because if you lose any connectivity here, or if you lose, suppose some software malware kind of thing happens only on this switch, or the physical NICs both go down, or a physical switch goes down, so that same machine is connected through another standard switch to another set of network cards, which is actually going to another physical switch. If you want to create, if you have that kind of redundancy available, and you want to set it this way. So the scenario here is, what if one virtual machine needs to be connected to two standard switches instead of one? So how do we do that? So that is also simple. Obviously, just like the physical server has a network card, there is virtual machine that have network cards as well, right? So this network card, first network card is through this it's connecting to, well, this, and the second network card is connected to this. So through a second network card of our virtual machine, you're connected to a second or another standard switch, which is connected to a separate set of network card, physical NICs, which is connected to separate physical switch as well. So the same virtual machine can be connected. So how is it possible? We just need to add a second NIC inside a virtual machine and connect it to a separate virtual standard switch. So that's how we can do this. So I'll just go back to my environment, and here VM02, if I just check it now, I'm going to right click and edit settings to a VM02, and for this setting the machine has to be actually down. Network adapter 1 off, virtual machine 2 is connected to virtual standard switch 2. I want the same machine VM02 to be also connected to the port group 1 of virtual standard switch 1. So VS2 or virtual standard switch 2, it is connected, how to be connected to virtual standard switch 1. So there is a add new device option here, and once we click that, So what do we want to add? Is it the hard disk? Is it the network controller? No, just the controllers, storage controllers, and then there we go way down to the network adapter. So if we click that network adapter here, so it adds a second NIC here, and obviously we just need to connect it to the correct port group. So the same machine will be connected to two virtual standard switches. So I'll click browse, and one network card connected to VS2, the other one I'm connecting to VS1 now. So one virtual machine connected to two separate we can say network flows. So 2 adapters, 3 adapters, 4, 5, 6 adapters per virtual machine. Yes, you may add those as well. And obviously it will grab IP from DHCP. I'm going to press OK here. Well, if we check the diagram, so another network card connected to another standard switch, two different sets of physical NICs, and suppose a totally separate physical switch. So these are some of the scenarios we talked about. First we explored all the features of one standard switch, then why would we need multiple standard switches, and then if one virtual machine wanted to connect to two standard switches, then what? So there could be many other scenarios as well, but these are some typical ones that you would face. And what are so we try to explore all the standard switch features there and how do we connect to virtual machines. Now after standard switch, obviously we need to have another feature. There are obviously many other services, many other features in VMware vSphere, which will totally be depending on this standard switch's correct configuration. So one of the features is the Vmotion as well, which is that you would want to migrate a virtual machine over the network from E6i2 to E6i3, or E6i3 back to E6i2. So this is moving a machine while it is shut down, moving a machine while it is suspended, moving while it is actually powered on. So any of those scenarios, how do you really migrate a machine? If your underlying virtual standard switch configurations are okay, obviously, then you can really migrate the virtual machines as well. And I'll just grab stuff. So what we need to do is, first we talked about the standard switches. Now we're going to go for migration. I need a cleaner lab here to really explain, first of all, why would we need to migrate a virtual machine, and then obviously how to do it and what are the requirements. So we have a virtual machine that is on top of one of the data stores here. Its virtual disk is on a data store, and that data store is on top of a LUN. So that's the vendor related environment or recommended environment. So this is VM, and this is the vDisk. So the migration can be done. Why would we need a migration? First of all, obviously, and I'll just go for Vmotion here. So we would need migration when we have this physical server. It is going through performance degradation, right? So if the underlying hardware, well, just ESXi host or hypervisor, same name, is facing performance degradation, then we need to migrate a VM to a better performing host or ESXi host. So you would need to move a virtual machine from one host to another if the host is facing performance degradation, but Vmotion cannot help. So where does it not help us as well? So Vmotion cannot help if a host crashed. It cannot help us. So the host has to be up for the virtual machine to migrate. So that is a common misconception that I find then when we are talking about next topics like HA, high availability. That what happens if the host crashes? So at once students say that well, virtual machine will migrate. No, virtual machine will not migrate. It can fail over, but if it's just that if the host goes down, migration cannot help us. So the host is facing degradation of performance. That's where you migrate. But the host crashes, then so Vmotion cannot help if a host crashed. Either FT, fault tolerance, offering failover to another host will help, or the VM simply gets, and there you go, restarted on the other host. So or the VM of the crashed host simply gets restarted on the other host, which involves downtime. So users are effectively disconnected when a host crashes. Now if you haven't configured FT, obviously if you haven't configured that, but you did configure HA, high availability, which are both cluster features, and we haven't created cluster yet. So if FT is not configured but HA is configured, then the virtual machine will simply be restarted to another host, which means users are effectively disconnected, and they can only reconnect when the virtual machine has started on any other host. So if crash happens, we must have, for critical machines, normally we configure FT or fault tolerance for just the critical machines, and otherwise if FT is not configured, which is a cluster feature, then the other cluster feature is HA, or the HA feature. VM of the crashed host, simply VM, obviously it will be VMs, oops, did I put, well, the crashed host simply gets restarted on the other. So we're gonna discuss in detail and configure those options as well once we go for cluster. But we just need to remember one thing, that Vmotion is not gonna be of any help if the server crashed, but it's gonna be helpful when you have really degraded performance and users during peak hours are complaining, hey, can you do something about it? Our virtual machines, that virtual machine that I'm connected to, that virtual machine will be a server, right? File server, web server, any other. So I'm opening my file, it's opening, it's taking forever, and it's not closing, it's not saving anything, it's freezing. Then you just simply come down to the physical host and check it out, that how many virtual machines are there. Obviously, suppose it's a peak hour, so many virtual machines are there, and all are busy. You're connected, your users are connected to pretty much all those machines, maybe 500 here, and 2000 users connected here to this virtual machine, and 900 users connected here, and there are 10 more such machines. So definitely uh, every virtual machine is grabbing that CPU and memory for its own use. So in that case, you realize, okay, this is because of this during peak hours the performance degradation happened, and then you see, oh, E6i3 has 70% CPU available, or okay, 40% CPU is available, and 60% is being used. So why don't I just migrate while the users are working on it? I'll just simply migrate the virtual machine from E6i2 to E6i3. What users will see is that there is a little freezing, like the user is trying to connect or click the files, and the users can't actually um, click it. It's just frozen for a few seconds, and that is the time when the virtual machine is just migrated, and the users, all of a sudden it starts working, and in fact it starts working pretty good. So the virtual machine reaches here, and it has a cutover here of the connectivity from E6i2, and it will at once in seconds or milliseconds actually, it will be connected here. So overall, first we talked about the reason, and then we then see that the virtual machine moves in seconds from one hypervisor to another without moving the disk. The disk is on top of a data store that is on top of a LUN, and that LUN is connected to this hypervisor, and the same LUN is connected to this hypervisor as well. Or maybe this one same LUN is connected to the rest of 199 hypervisors, or out of 203 hypervisors. Suppose you have that many. So that's a good thing, since the same LUN is connected to all hypervisors, so the same data store is available to all hypervisors, and virtual machine can move from one hypervisor to another without losing its connection to the disk. So if the virtual disk does not move, we're good, because the virtual disk typical sizes, maybe it grew up to 200 GB or 500 GB or even 60 GB. Even then, it will take some time too, and that would be very bad degraded performance if virtual disk had to move during peak times. So obviously then it will be unacceptable. The performance will be so bad. So the disk moving, if it's not done, then the Vmotion can be done really fast. And before that, SAN is a must. And that's why every environment will have SAN, either vSAN or the actual SAN. So we understand that it's in seconds the virtual machine moves from the memory of one host, physical host, to the memory of the second physical host. So it's the memory contents, which are very small in size, that move or travel over the network from one physical host to another. And the virtual disk is just not moving. It's just in milliseconds it's disconnected and connected again here when it reaches on the other machine. So what are memory contents then? Memory contents are, the virtual machine is actually loaded on the memory of the server here, and oops. And memory contents are the information, okay, these many users are connected and this file is open. Whatever activity is going on the virtual machine, that is a total memory content there, and that is very small in size. So if that has to travel, that travels real fast over the fan, while over the LAN, sorry, and while the virtual disk doesn't have to move, and it simply gets connected on the other side. So this, from the memory of one server, the machine simply lands on the working machine simply lands on the memory of the other server, gets registered here right away, and then it starts working. There's a small cutover in seconds. It's cut from E6i2, and it's connected to through E6i3 to the virtual machine. So this is overall excuse me, the process of the virtual sensors. Now let me just grab the file for that so I could also show you. Okay, so about the standard switch, let me just grab that file, and we're going to talk about the prerequisites as well, and some of the other details of this. Just grabbing, yeah, got it. On the other screen I'm doing this. Now, so this is going to be some of the prereqs that are going to be shown. So first of all, in the slide, normally I also put that at the start, so I should not forget it when we're doing the lab. That in start, make sure that the VM you are using for Vmotion does not have a CD DVD mounted to it. Does not have ISO. Obviously, we have ISO of OS or application mapped to virtual CD DVD. So ISO can be mounted to CD DVD, obviously. So if the ISO is mounted, then you won't be able to migrate the virtual machine. So normally it's Vmotion. So that's a very common error that we see. Sometimes it becomes so ridiculous, like so the ISO of Windows 2019, suppose, or Linux, Ubuntu is attached to the virtual DVD of a virtual machine, but what happens is that sometimes the error does not even come. But when we are trying to do the Vmotion, normally we're supposed to see and supposed to be able to select of the destination host. So suppose your machine is on E6i2. You want to migrate your machine to E6i3, but you don't see E6i3 in order to select it. If you don't see the destination host to where you want to migrate to, so how can you migrate? So that is weird, and in one class we had to troubleshoot for 2 hours to know that why the destination host is not showing for migration. And it turned out that that virtual machine had a OS ISO of the operating system mapped to it. As soon as we removed it, then we could see the destination host to which we wanted to migrate. So sometimes it gets really annoying that it does not even show you the error why the destination host is not even showing. And anyway, if we go ahead, so well, we have talked about the main purpose of migration. It is only useful when the host is powered on. If it crashes, then it's not the migration that will save the machine. It will be other features like fault tolerance, where there is no downtime and fails over, or the HA, where there is a downtime but it's still after the machine is restarted, it still keeps on working. Okay, so in this detail, I should write that FT offers zero downtime, while HA, high availability, has a downtime. So that's one more point here, and we're gonna obviously be separately discussing these options. Okay, so where was I? Yeah. So there's cold migration and suspended migration there, and Vsphere V Motion, which is the machines powered on, and Vsphere Storage V Motion, where you can just move the virtual disk of a virtual machine from one data store to another data store. So that's Vsphere Storage V Motion. Now, cold migration, obviously the migrate a virtual machine that is powered off, suspended. While it is suspended, it can be migrated as well. Vsphere V Motion, migrate a virtual machine that is powered on, and Vsphere Storage V Motion, migrate a virtual machine's files while the virtual machine is powered on. So these are the four types there, and we're going to try all. And a maximum of 128 concurrent Vsphere vMotion accesses to a single Vmware vSphere VMFS data store. So it's just 128 concurrent vMotion accesses. So vMotion, it's accessing one data store. So to the VMFS data store, there can be 128 concurrent vSphere vMotion accesses. So that just means that virtual machine is going to access or connect to a data store, and it could reconnect to the data store as well. Suppose there's a storage, vdisk is about to be moved from one data store to another data store. Okay, I create data store here. So in that case, it has another access. So if the virtual machines are accessing the data store for the purpose of vMotion, so there could be 128 such accesses at one time allowed, and a maximum of 8 concurrent cloning, deployment, or vSphere storage vMotion accesses to a single VMFS data store. So normally 8 machines can be cloned at the same time, or 8 machines can be deployed on the same time, or 8 machines can be vMotioned at the same time on a data store. This is the same table again, but now it has more details here. The migration, the virtual machine migration depends on these factors, especially the CPU. It depends on the CPU as well. CPU compatibility really, if you have an old hypervisor and you then have a new hypervisor and it's a significant difference, then also vMotion will not happen. So what's that about? We're going to talk about this now. So first of all, it says here that there's a migration type is cold, and for that virtual machine power state can be off. So virtual machine can be off, right? And change host or data stores. What you can do when the machine is off? Yeah, you can change the host, you can change the data store as well. You can travel from one host to another, and you can move a machine files, machine storage from machine files from one data store to another data store as well. Then there is across vCenter servers. There's yes, so if you have multiple vCenters, then also a powered off machine can be moved from one vCenter to another vCenter. And if the machine is powered off, do you need actually a shared storage? Do you need SAN there? So no, you don't need SAN. Even local disk-based SAN is also okay for this. So that's one thing, and other is, well, at the end it says different CPU families. Yeah, this is allowed for if the machine is off. If now, what does that mean? Different CPU families, right? So either you have AMD CPUs in all physical servers, but they are older and newer, right? And there are Intel CPUs. So you have suppose um, these are physical hosts, and this host was purchased in maybe 2012 2014, and that's way back, right? So and then this host was purchased in 2017, and this is 2019, and this is 2020. You just purchased it. So if there are older physical ESXi hosts there, um, now there are CPU families, right? So Intel has a CPU family, and CPU family just means that Intel keeps on, and this goes for every product that you have Intel processors that are released in 2019, and then there's a small amount of no significant architectural changes, and new processor is or newer processor is released in 2020. So 2019 Intel processor for Xeon processor and 2020 Intel Xeon processor, they may not be having big differences, so they may belong to the same family of processors. Suppose Intel Xeon 2014 released processor uh, is there in your company in a physical machine as well, physical server, but obviously that would not belong to an Intel processor released in 2020. The 2014 released processor may have significant CPU architectural differences from the processor released in 2020. So I'm sure they will not belong to the same family. If the two hypervisors who have a processor that belong to same family, yes, the virtual machine can migrate. If there are physical servers with same company Intel processor, company same, but the family is different, and family different, so family just depends on significant difference of features, right, of CPUs. So if it is not belong, I'm going to show you what do we mean by a family, how many families are there in Intel, uh, and what are they called, and they're also called generations. So there is MIROM generation, there is penRAND generation. So they call it generation, but it's just like if in 2018 it was released, and then 2020 released, and they may not have very many significant differences, so they can belong to same family. Intel decides which set of processors can belong to which families, obviously. So an older processor may not belong, they may belong to the same vendor, but they don't belong to the same families. If they are different families, then migration cannot happen as well. Obviously, when we say same vendor, different families cannot go. So if this is AMD and this is Intel, obviously it will never work. The virtual machine migration will not happen if they are totally different vendor for the processors, because virtual machine does need to be having virtual machine moving from one host to another require that CPU must be compatible of both hosts, and there are some features there in VMware that actually hides some of the incompatibilities of two hosts. Suppose you purchased in 2019 December of HP server, and then you purchase in February, just after 3 months you purchase another physical server. Now but it happens that it's not the same processor. By that time Intel had came up with and released a new processor with, or newer processor. Now there are slight differences with each other, so those incompatibilities, slight incompatibilities, can be hidden with some of the features VMware provides. So your VMware just says that, or the Vmotion service simply says that, VMware says to the Vmotion service, hey, there's no incompatibility between these two processors, so please migrate from this server to this server, and it's okay. While there may be some differences in the features of the processors of two physical servers. So VMware just fools the Vmotion into thinking that it's exactly the same features, so please go ahead and migrate. So if there are different vendors, obviously that's never going to work. So suppose you have AMD. Now it's this is old. Suppose you have 20 physical servers. Um, they have Intel, and you have 11 servers that have AMD. So it's better to create it's better to create a cluster. Normally you group the servers together to offer some high availability features. So when you create a cluster, you group the similar hardware type servers in one cluster. So in one company, you can create one cluster with all servers having AMD processor, another cluster that is having Intel processors based machines, physical servers. So you can create separate clusters there, and then hide some of the incompatibilities of those processors if they were a bit newer and a bit older servers. So VMware provides all those features that were slight incompatibilities of the CPUs can be hidden from Vmotion. So overall, obviously, these are some of the points there. Now, if the machine is off, it's okay.
Amir, just a question. Is there a website where you can compare the water generations and everything else of those systems?
Yes.
From VMware?
And VMware. No, you want to compare. You want to just know that which CPU is in which
Yes.
family.
Yeah.
Which generation?
Which family and all?
Oh yes, that is which CPU in family. That would be coming from actually Intel, but
Okay.
VMware, I have to dig it out as well. I'm sure it's there, but I have to dig it out myself. And I would go for basically Intel website. And
Okay.
yeah, if you find it, let me know. Otherwise, I'm gonna show you within VMware. There's a area, so I have to install cluster first. We will be going there, and then I'm gonna show you all the families there that VMware has lined up already.
Okay, fine. Thanks.
And okay, guys. So here, then there's suspended machine, right? And the suspended machine is, well, it's suspended. So first of all, virtual machine, when it is powered on and you're working on it and there's a lot of windows open, a lot of processes are going on in the background, you didn't close any of those processes, you didn't want to close the enterprise application on top of that virtual machine, but you still want to stop the virtual machine. So you don't want any of the opened windows to be closed, but you still want to stop the virtual machine, so you suspend it. Now, in the suspended state, you can move a virtual machine from one host to another. Yes. Across vCenter. Yes. Do you need shared storage or SAN for that? No. But the only thing that you do need now is that if the machine is suspended, it would still be able to, and if it is moving from one server to another, it still would need processor or CPU compatibility. So that's just by design that suspended machines need CPU compatibility, and they better be belonging to the same family of Intel processors. There's a Vsphere V Motion where now the machine is powered on, and this is what will support you a lot in your production environment where tickets start coming during peak hours that, okay, we're not able to really work on the machine, it's unacceptably slow, so can you just fix it now? And if you have configured Vmotion, it's not if, you must configure Vmotion, it has to be there, and you just simply Vmotion the machine and the work goes on. So Vsphere Vmotion, the machine is powered on, Yes, you can change the host, one host to another. Across vCenter, yes, you can do that too, still. And yes, now you need a SAN for that, shared storage. Because you're not gonna move the virtual disk. You're going to only move the memory contents of the virtual machine from the memory of one host to the memory of another host. And must meet, yeah, obviously, when the virtual machine started, it has to be the CPU of both hosts must be belonging to the same CPU family. And vSphere storage vMotion. So storage vMotion, you want to, when you see virtual machine storage, VM storage, so that only means the virtual disk. So all the files of the virtual machine on the data store that make a virtual machine work, those files are called VM storage. The virtual disk file, VMDK file, and VMSD file, and config file, right? So VMX file. So all these files that make the virtual machine work, they're called virtual machine storage. But typically, that's the virtual machine folder inside which the files are. So that virtual machine folder you want to move from one data store to another. So if the virtual machine is powered on and for some reason, well, if the data store is running out of space, right, that would be the main reason. If the data store was on a not a very good performing disks and you had to move the virtual machine files from one data store to another, obviously it will not be a good experience for the end users if you had to do that during peak hours. Otherwise, when you're talking about storage movement, it has to be during off-peak hours or weekends. So vSphere storage vMotion. So if the machine is on, yes, you can do that. You can move the files, underlying files of the virtual machine, even if the virtual machine is on. Across data stores, yes. Across vCenters, yes. But do you need shared storage for that? Do you need SAN for that? No. It's just virtual machine files. It's like file copying from one place to another. And yeah, CPU has nothing to do with that because you're just moving virtual machine files. And then cross-host vSphere V Motion. What that means is not only that, so suppose this is a virtual machine VM and this is the vDisk. Now we were talking about, when we're talking about vSphere V Motion, we're moving a virtual machine from host 1 to host 2, right? We're just moving virtual machine while virtual disk we're not moving when we're talking about vSphere V Motion. When we're talking about vSphere storage V Motion, we're only moving the virtual disk from data store 1 to data store 2. We're only moving a virtual disk now. So when we talk about vSphere storage vMotion, when we talk about cross-host vSphere vMotion, we're doing both tasks at the same time. We're moving a virtual machine from host 1 to host 2 while it's not simultaneous. First, you can choose. You want to move first the virtual disk from one data store to another, and after that, I'm going to automatically start moving the virtual machine from one host to another as well. Or you want to move first the virtual machine from one host to another, and then you want to move the virtual disk from one data store to another data store. So this is two tasks in one. They will just automatically start one after the other, whichever you choose first. So vSphere vMotion, just host changing, storage vMotion, just the data store changing for the virtual disk, and cross-host vSphere vMotion is both are changing at not simultaneously but one by one. Okay. So here we understand first thing, different CPUs are okay in certain situations and they must meet CPU compatibility in other situations. So which one are those? This table simply explains all that. If we go ahead, Vsphere V Motion migration. So yeah, it just Vsphere V Motion migration moves a powered on virtual machine from one host to another. So that's what's the benefit? Improves overall hardware use. One hardware is used a lot and the other is not being used, so just migrate to the less used hardware. Continuous virtual machine operation while accommodating schedule. So vMotion just lets you keep virtual machine up. You don't have to shut down and move virtual machine. It's powered on and move it. That's it. VMware vSphere Distributed Resource Scheduler. Now this is an upcoming topic. DRS, Distributed Resource Scheduler, balancing virtual machines across hosts. Now DRS is one of the most important features of vSphere vCenter, where it automatically analyzes every 5 minutes. It does the analysis that which host is offering more CPU and RAM and which host is offering less CPU and RAM. So whichever is offering more, DRS automatically vMotions the virtual machines to that host which is offering more CPU and RAM. So always when DRS is on, always the virtual machine has the best performance, because it's going to keep on vMotioning the virtual machine to the best performing host. And if it discovers there's a better performing host, it will still vMotion to that host. So virtual machine will always have the best performance. But obviously this DRS feature comes with the most expensive license, Enterprise Plus license. Then DRS comes. Okay. How vSphere V Motion migration works. So we talked about that. It's the memory contents that go from one host to another. Obviously, it's not copying the virtual machine. It's moving the virtual machine, right? So in the diagram, the source host is E6i1 and the target host is E6i2. The source host and the target host have access to the shared data store holding the virtual machine's files. Obviously, it has to be SAN. Without that, vMotion is not possible. Actually, technically, you don't have a SAN. Well, you can still move the virtual machine, but obviously, without SAN, you have to move the virtual disk as well, and that's where the performance is gone then. So obviously, technically, you can move. It's just that then move it on weekends. So SAN is there, and the main feature is that you can move it while the users are working. So that's a really good business continuity feature. Okay, the rest are we may have talked about. Okay, vSphere V Motion migration requirements. A virtual machine must meet the following requirements. It must not have a connection to an internal standard switch, virtual switch with 0 uplink adapters. What's an uplink? So uplink is, I was giving that example. In fact, this diagram here. You can have a standard switch without connectivity to any physical adapter as well. Technically, yes, you can have. Now, we know that when we create a standard switch, we have to connect it to some physical adapter, but technically, you can have a standard switch that is not connected to any physical adapter, but it's still working. How? There are two virtual machines here, and these two virtual machines are connected to a standard switch that is not connected to any physical adapter. So what happens? Well, they can connect to each other, right? They can connect to each other, but they cannot connect to the outside world. That's it. So technically we can have a standard switch without physical adapter, but it does not offer these virtual machines outside the hypervisor connection. So it's just that. So if it's not connected to any physical adapter, this is called having zero uplink, right? So that is that zero uplink here. So obviously you cannot migrate a virtual machine away from the host if it's connected to a virtual standard switch that has no physical adapter. So how can you migrate? Obviously. It must not have a connection to a virtual device, CD, DVD, or floppy drive with a local image mounted. So we talked about that before. The ISO of operating system or an application should not be mounted here. If it is mounted, you can't migrate. So it's saying that too. And it must not have CPU affinity configured. Oh, what is that? Affinity. Now, affinity rules are coming your way. It's another upcoming topic. Affinity rules are normally that you have VM to VM affinity. You have another rule called VM to host affinity, and then host to and then there's VM to CPU affinity that you're seeing here. CPU affinity just means that suppose there's a host here, physical host, and the virtual machine on top of it. It has an application here that really needs a lot of GPU, graphical processing units, right? So that is available. That GPU is available with this CPU, right? So this app will not work if it is migrated away to another host which is having a processor that does not support GPU. So this app, or you can say just that this CPU has those specific features that an app needs. So you create a CPU affinity that, okay, this virtual machine cannot be moved away from this host. Why? Because the application inside needs that CPU power, which is not available in any other host. If that's the case, then CPU affinity, you can create a rule like that, and we're going to see that how to create affinity rules later. But that's it. That you don't want a virtual machine to be moved away if any other host does not offer that same CPU power that it needs for it to run. So then it says here, okay, CPU affinity is configured, then it won't move. It cannot be migrated. If the virtual machine swap file is not accessible to the destination host, so swap file is like a page file in Windows that certain part of the disk is used as a memory. So if the virtual machine swap file is not accessible to the destination host, so you're moving from one host to another, and the other host is connected to a LAN or storage available to the other host that the virtual machine is moving to does not have space to create a swap file, then in that case it's not going to migrate as well. And then the final is if a virtual machine uses a RDM, raw device mapping. Oh, what is this? Raw device mapping is a special feature that is also called pass-through disk in Hyper-V, and that is RDM in VMware. So what does it do? So if you suppose have a physical host, so if I say host, that also means ESXi host, right? So you have a host here, ESXi host, and you have a virtual machine on top of that, and that virtual machine has access to LANs. Now okay, that virtual machine has access to LAN, and so there are 2 or 3 or 20, 30 or 200, 300 LANs there, right? So LAN 1 and LAN 2. Okay, now this virtual machine has a SQL Server app, and that really requires a lot of IOPS, input output data per second. So it's really writing a lot, it's reading a lot, and writing and reading, writing and reading, writing and reading a lot. So obviously it needs a SSD underlying, and there's a lot of IOPS it needs. So what happens is when you're connecting the virtual machine, you have an app on the virtual machine. Virtual machine in turn is connected to a vdisk, virtual disk. Vdisk is on top of a data store, right? Virtual machine, vdisk, no, it's disk. Okay, virtual disk is on top of a data store, right? And then from data store, the request goes to the actual LUN. Hey, can you really work? Can you really read that? Can you read that file right away? Now this is happening in seconds, and thousands of reads and writes are happening. But the virtual machine talks to virtual disk talks to data store talks to the LUN. How about, and then SQL Server says that, or the users using that says that the read and write is slow, and we need more read and write or IOPS. Reading the disk, writing the disk is slow, and our application is really falling behind. So that's a complaint. So you decide that how about we introduce a LUN here, LUN 3, and that LUN is raw. So it's not formatted with anything, not even VMFS. Now, normally what happens is that this machine, this LUN 1 here would have other virtual machine virtual disk as well. It's not, one LUN would have obviously sharing the disk of other virtual machines as well. Plus this virtual machines disk. So other virtual machines virtual disk also are using the same IOPS, read and write. Either that's also read and write. That's also read and write, right? So that's why the SQL Server that is heavy on IOPS, it's saying, oh man, I really need more IOPS, and I'm on a shared LUN here. Everyone's using that, so read and write is so slow, I need faster. So then comes this concept of RDM, which is that, okay, your first virtual disk is having an OS. How about we give this one virtual machine access to the whole LUN? And then on top of this, we can deploy this app, and this whole LUN would be only dedicated to this virtual machine here. So the reads and writes, IOPS would be very, very good. So, and also it is raw, which means what? No data store on top of it. This is just for the use of the virtual machine. You want to format it with NTFS, go ahead and format it. You want to put SQL Server on top of that, go ahead and do that. And Microsoft SQL Server, right? You want to use this, but when you deploy an application here, it's going to have like huge IOPS. It's going to have good speed there. No other virtual machine is allowed to access this whole RDM, raw device mapping, or the whole LUN is only dedicated to this virtual machine. So when it runs its application on a raw disk, it has huge IOPS then. So and other virtual machines are not using that, so it's not a shared LUN. So this means that all the IOPS coming are only coming from this application here. So when you provide a raw LUN to a virtual machine, that is RDM. So, and that is called pass-through disk in Vmware, Hyper-V. So that's a raw disk available for good performance, especially the read speed is then immense. Okay, so it says here, if a virtual machine uses a RDM, the RDM and the physical disk to which it maps must be accessible by the destination host. So that's a simple one, that one host is here and the other host is here, and the virtual machine on top of it is, so that's the VM, that's the host 1, H1, H2. So the virtual machine has an access to an RDM disk, right? So that RDM, when the virtual machine migrates from here to there, so VM should be able to access that RDM from the destination host as well. If not, then it's not going to move. It's not going to migrate. So if it has access to that RDM from the other host as well, then we're good. Then it's allowed to migrate. So these are some of the migration requirements, or these are the scenarios where virtual machine cannot, it should be called restraints actually. Vsphere V Motion migration restraints. These are the scenarios where if they are there, virtual machines won't be able to migrate actually. And so yeah, swap file, we talked about that, page file, or that much area in the disk that is used as a memory. Okay, Hugo says I love RDM. Oh, that's great. That's cool. Okay, so source and destination host must have these characteristics. It just says that you should be providing 10 Gbps network instead of 1 Gbps network. And other thing is that there is CPU feature sets of both source and destination host must be compatible. So we talked about that. CPU features better be compatible or migration will not work. There are some features can be hidden by using, and this is when we create cluster, EVC is one of those features that are provided to us, that if there are incompatibilities between the two physical machines of a cluster, then EVC will simply fool the Vmotion into thinking that there are no incompatibilities. Go ahead and migrate while there are slight feature differences between the processors of two hosts. So there is EVC that fools the Vmotion into thinking they are same processors, and there is another feature called compatibility masks. So these are the two features. We're going to be checking EVC in cluster, right? So other than that, it goes on into then CPU compatibility. CPU compatibility masks. vCenter server compares the CPU features available to a virtual machine with the CPU features of the destination host to determine whether to allow or disallow migrations with. So yeah, what we were talking about just now, by applying CPU compatibility mask to individual virtual machines, you can hide certain CPU features. So, well, that goes on and on. We need to do the lab as well, right? So I'm just going to go ahead and be brief on the rest of the slides there. CPU constraints or on Vsphere V Motion. Now, this table actually talks about what kind of CPU incompatibilities that can be there. So CPU characteristics, exact match required, and reason. So clock speeds, cache sizes, hyperthreading, and number of cores. So exact match is required or not applicable. Virtualized away by the Vm kernel. So these things are virtualized by ESXi hypervisor. So these doesn't have to be exactly the same. And manufacturer, Intel or AMD, family and generation, Opteron 4, Intel, Westmere. So yes, exact match is required when it comes to family. Instruction sets contain many small differences. So it has to be either Intel or AMD, but they cannot be one Intel, one AMD. And presence or absence of SSE3, SSSE3, or SSE4. Now these are then it goes down in depth into Intel processor features, and there's a very long list of Intel processor features there. So, but these features relate to multimedia instructions usable directly by applications. So you're doing live streaming there, and you're running some big graphics applications there. So they really need some of those Intel processor features there. So it's going to be checked, and if they have to be exactly matching on both, source and destination servers. Virtualization hardware assist, 32-bit not applicable, but 64-bit VMs on Intel. Obviously, virtualization hardware assist is that it's gonna detect the hardware and then go ahead. And execution disable, NX XD bit applicable but customizable. Guest operating system relies on NX XD bit if detected. applicable, but so these are some of the processor configurations for different applications and operating systems that they really needed be there before the virtual machine migrates. So then now this is the screen that I was saying that it will come when we go for clustering EVC, and that is AMD Opteron generation 1, 2, 3, 4. It just shows you the list of all generations. What it does not show is that which processor exactly or set of processors belong to which generation. And yeah, there's that if we click, this is a picture, so when we go there, I'm going to show you that Intel hosts EVC. That's going to show you the all Intel generations there, 8 or 9 generations there, but what it's not going to show is that which processor it belong to. So this is a very interesting EVC feature, enhanced Vmotion compatibility. What is interesting about that? When you select a specific generation in Intel, it's going to check your laptop or desktop, and it's going to tell you which generation your processor is. But this EVC is not meant for our laptops and desktops. It's meant for server side, right? It's meant to detect server side of server grade processors. Still, it tells for some laptops. It tells that which generation your processor CPU belongs to. And okay, so it shows a cluster enabled for EVC. EVC works at the cluster level using CPU baseline. So I've talked about that. When we come to that, we're gonna talk about EVC, and I'm gonna show you everything. But yes, EVC's main job is to hide incompatibilities of the processors. And it goes on and on that more detail about CPU ID compatibility, and there is NX and XD chip that has to be same for both sides that Vmotion checks, and then there is in virtual machine settings expose the NX XD flag to guest, and that just means that the both processors should have this NXXD feature available, which is normally for virtualization technologies that it is used. And there is to identify CPU characteristics, use the server and CPU specifications, or use the VMware CPU identification utility. Now that identification utility, I need to actually check what was that. So there was a screenshot there, but normally it is VMware CPU identification utility. If you Google that, you will be able to find that. And other than that, yes, this is again that error if you have ISO of operating system attached. So, and this is just giving the whole information about the Vmotion procedure from the point of view of the virtual machine. So this is okay. So that's a full set of procedure of Vmotion. We're gonna check it out later. I'll just upload this slide there, and you can just go through that. But we're about to go through that anyway. So we're going to now check our environment, how to do Vmotion. So one additional comment about what the Vmotion checkpoints record all devices and their status, CPU registers, main memory contents, serialization of the status for transmission over the network. So Vmotion normally requires that these steps be done, and when we do a Vmotion in the background, status of the devices, CPUs, what CPUs are there, and are they compatible with each other, memory contents, what is going on the virtual machine, what size is the memory content, and serialization of the status for transmission over the network. So one by one, all the steps in the background, although it happens in seconds, but in the background it's very organized, obviously. Now we finally come down to lab, and we need to go through the checklist there that what our environment has configured and what our environment has not configured. So for that, okay, let me check it out. Yeah, CPU compatibility, first of all, obviously this is one thing that we can be sure about, because both of our hypervisors are on top of our virtualization software, which is on one physical machine. So that's why CPU compatibility is not an option, is not a problem in our specific environment. But when it comes to clustering, then I will show you the EVC feature, or enhanced Vmotion compatibility. That EVC's job is to hide CPU incompatibility. So I'm going to show you in a production environment then how do we really use that. So CPU compatibility, yes, is check, it's okay for us. Vmotion interface, minimum 1 GB. Now our laptops I think have more than 1 GB adapter, but minimum is 1 GB PS adapter that is needed. Shared central mass storage, yes. Do we have SAN? So we have a software SAN there. Same naming for virtual port groups. Okay, so port group naming. So port group naming is supposed to be same for. Remember that when the host is deployed first, virtual standard gets created, and when by default a virtual standard switch gets created, a port group by default gets created too. So this happened obviously in all the hypervisors that we deployed. So the first port group of vSwitch 0 is named VM space network. So that port group is available in all three hypervisors. So this means we have a port group, same named port group in all three hypervisors. We just need the ECXI2 and ECXI3 because we're going to be doing all the labs here and not touching ECXI1. So yes, we have a port group in ECXI2 and 3, which is named VM space network. In fact, yeah, we're there already. So I'll just click ECXI2 and ECXI2, right? So virtual switch 0, and the one port group name is VM network. This is ECXI2. If I go down to ECXI3 on the same view, I'm going to go down to ECXI3. It's going to take us to the same view. ECXI3 virtual configure virtual switches and vSwitch 0 there as well. And yes, there's a port group called VM network here as well. So this is ECXI3. I go back to ECXI2 and this VM network. So yes, we have a port group that is the same. And sufficient resources on the target host. Well, yeah, we have 6 GB RAM in one. I have 6 GB RAM in ECXI2, and I have 4 GB RAM on ECXI3. So it's going to be okay for the virtual machine migration, because you know what, the virtual machine I have does not have an operating system, but even if it has an operating system, it's going to be okay, because the virtual machine's virtual disk is the main component that has big size, and virtual disk is not moving in our Vmotion lab. So yes, we have sufficient resources for the virtual machine Vmotion. At least one vSphere Essential Plus license, so that is minimum license, but we have trial version for Enterprise Plus, so we have all the features there. Still, there are some more requirements that need to be done. So now guys, this is going to be long, so let's take a break, and then after that let's go ahead with fulfilling the actual requirements. There's only one, that is creating a VM kernel port, so we're going to be implementing it soon. So let's just take a break here and then come back. So Vmotion here. So class starts 352 42412. Okay, so starts US 412. Canada 512. Zooming. Alright, so we are going for the Vmotion, and if we check the list here, so before that we were talking about some compatibilities. So CPU compatibility is okay for our machines. Vmotion interface, well, minimum we have 1 GB PS network adapter. Shared central master, yes, we have SAN, and same port group, same name port groups are there as well. Sufficient resources on the target host, hopefully we have that, and minimum license is Essentials Plus, but we have Enterprise Plus trial version. Then Vmotion of a virtual machine. So our CPU requirements are okay, as we have same CPU for our both hosts. Then let's confirm our network settings. So that's where we need to check out what to do. So we need to create Vm Kernel Adapter. We need to create kernel adapter. So why do we need that? We talked about that before as well, that we use Vm Kernel port or Vm Kernel Adapter for introducing some advanced features, and Vm Kernel Adapter actually lets us configure the networking side of the advanced features. So Vmotion needs to be configured for that. Vm Kernel Adapter needs to be configured as well. Also, when we create Vm Kernel Adapter, it has to be for the Vmotion. So Vm Kernel Adapter for Vmotion, when it is created, we need to set aside static IP addresses or DHCP, but separate IP addresses, dedicated IP addresses for the service of Vmotion. We need to set aside, like Vm Kernel Adapter when we create for E6i2. So two IP addresses need to be assigned. So E6i2 will take part in the Vmotion SSI3. I am not configuring it for SSI1 because that machine VCSA were just keeping all the testing and all the things there away from E6i1. So in order to configure Vmotion service here in E6i2 and 3, we need to make sure that we have Vm Kernel Adapter. Vm Kernel Adapter will be created on the vSwitch 0 on both sides. vSwitch 0 on both sides, right? And vSwitch 0 is having Vm Kernel Adapter already, which is the, if I just show you there. So virtual switch vSwitch 0 of E6i2. E6i2 vSwitch 0 has already one Vm kernel port called management network, and it has its IP. This is pretty much the IP of the machine itself, but when we create another Vm kernel port for Vmotion, so it will require an IP of its own as well. So that's the requirement of, by design, that's the requirement for any Vm kernel port that we create. So let's create that now. Let's create a new Vm Kernel Adapter port group with the same name on both hosts, Vmotion PG. Give it 2 physical NICs, create it on a new virtual switch. Okay, this one, remove all the V switches if there are any to avoid confusion. So all the extra, all the other, okay, yeah, so remove all the other virtual switches. So first, the virtual switches, so we created 2 extra virtual standard switches. We need to remove them and keep only vSwitch 0 there. So remove all the other virtual switches to avoid confusion and keep only vSwitch 0. On the participating, now we have just 2 hypervisors, but any number of hypervisors on the participating ESXi hosts. Okay, so let's do this. First of all, I'm going to go to ESXi2 and remove the extra 2 virtual switches, so which is vSwitch 1 and vSwitch 2. Then I will start, because we did not create those switches in ESXi3, so we're okay. We just need to remove it from ESXi2. Then we're going to start the Vm Kernel Adapter on installation on vSwitch on ESXi2. Then we're going to go for ESXi3 and do that same thing there as well. So first remove switches, then add Vm Kernel Adapter. So I'll go to, alright, so ESXi2, configure virtual switches, and vSwitch 0 is there. So I'm going to go down here, and there's a vSwitch 1, right? So if I click or expand the vSwitch 1, and then this is the view of the networking options, and on the 3 dots you can see remove button here. So vSwitch 1 and then the 3 dots of just the vSwitch 1, there's a remove button, so I'm just going to click that, remove. I know there was one machine that was added, or 2 machines are mapped there, but I'm still going to remove that. In production environment, I would detach the machine from here and then remove it. So I'm going to press yes here for vSwitch 1 on ESXi2. So vSwitch 0 is there. I'll just collapse that so I can see how many are left. Okay, vSwitch 0 and vSwitch 2 are left, so the same way we're going to remove the vSwitch 2 as well, and remove that as well, and yes. So vSwitch 0 is the only one there, so that's the first thing we need to do. Now the second thing is to add Vm Kernel Adapter for introduction of Vmotion feature. So for that, I'll expand the vSwitch 0. First, I'm going to add Vm Kernel Adapter here for Vmotion on ESXi2. Then I'm going to go to ESXi3 and I'm going to add the Vm Kernel Adapter there as well. So vSwitch 0, I'll expand that, and so it is add networking here as well.
Amir, just a question. I am doing it on my ESXi1, which has a live machine, which I loaded on the VM. So if I do it on that, is okay? It won't interfere with my VCSA?
Well, technically it should be okay. I'm just trying to avoid it. We're still learning a lot of features here, and yes, any surprises can affect
Yeah,
us.
if it crashes, no problem. I'll reload the entire thing. I'll load up. I'll create the lab again.
Oh, okay.
I'm just going to do it that way. Yeah.
Sure.
Yeah.
So you can do it. Okay. So here, I'm clicking the vSwitch 0, and I'm clicking Add Networking. On the vSwitch 0 of ESXi2, now it says, hey, you want to add a Vm Kernel Network Adapter or virtual machine port group or physical adapter. We've gone through these 2 options before, but now we're going to add this feature, Vsphere V Motion. So for that, we need to create Vm Kernel Network Adapter. So I keep it selected and click Next. And then it says that you want to use the existing vSwitch or you want to create a new one. Okay, so I actually did not mention that before, but what we're doing is that we're going to go for vendor best practices because we can actually do that, which is that we can still create. Now, just now, yeah. So as we were talking about, and I did not put that before in the plan, that we're going to create a separate switch and two network adapters for each advanced feature that we introduce. For example, for now it's Vmotion, then later we're going to be installing fault tolerance FT, and then later we're going to be installing vSAN. So for all that, all those features, we're going to be using this technique, technique or vendor best practice, which is to make a separate virtual standard switch available, which is supposed to be connected to extra network cards. So why are we doing that? Well, because we have enough network cards, and that will. So technically, yes, we can we can just connect that Vm Kernel Adapter to this vSwitch 0, and all the Vmotion traffic will also go through that, and the virtual machine traffic is already going through that, suppose. But as a vendor best practice, we're just going to create a separate switch with two extra network cards dedicated to Vmotion on both of these hypervisors, VCSA 2 and 3. Okay, so if I go back to my options now, select an existing standard switch. So vSwitch 0 is there, and technically, yes, we can create that Vmotion on this existing switch, but we're going to create a new standard switch here to just for the and it's going to be dedicated for the Vmotion feature only, with its on set of two network cards. So new standard switch, and then click Next. And then there is a plus sign here, so we're going to just give it two network adapters and press OK. And then I'm going to click Next. Now this is on Vm Kernel Adapter. It is asking for specify Vm Kernel port settings, and this is the port settings or port group settings, we can say, but we can just give it Vmotion, right? Just Vmotion is okay. So network label is Vmotion or the port settings. Then there is VLAN ID. We don't need to give VLAN ID. Is it using IPv4? Yes, not IPv6. And MTU, get MTU from switch, yes. So maximum transmission unit, how much payload per packet it needs to take, which is okay. Then it also shows here TCP IP stack, which is so the whole TCP IP stack can be dedicated just for Vmotion, which simply means that suppose you're configuring the Vmotion on this Vm kernel port, and I select this, right? So this will just make me this will just make it available for me, the Vmotion, right? But technically, you can, suppose you say that, okay, I want to actually also introduce fault tolerance. Oh, okay, let me configure it on the same fault tolerance switch. Oh, I want to introduce vSAN. Okay, let me introduce the vSAN as well. So now fault tolerance traffic is a lot. So vSAN traffic is a lot as well, and Vmotion traffic itself. So just like we were able to create that on vSwitch 0 and the traffic will increase, so we can still share other advanced features on this VM Kernel Adapter. But Vmotion, I'm going to uncheck these two, and what we can do is, and that is only available, this feature is only available for Vmotion and provisioning is just deploying machines. So if I select this TCP/IP stack, this whole networking stack or set of protocols, the whole networking option will be only dedicated for Vmotion. So Vmotion is one of the most sensitive tasks going on there in a VMware environment, and that really guarantees good performance of virtual machines. So that's why dedicating only for Vmotion means that none of the other features now, after it is created, will be possible to be configured here on this VM kernel adapter. So you will have to create a new VM kernel port with a set of new IP addresses to configure fault tolerance, and if you want to add any other advanced features, you can do that, but not on Vmotion. Vmotion will not be sharing this configuration with anyone else. Given that it is so sensitive, yes, this is a good idea to go for dedicating this whole VM kernel adapter only for Vmotion and not to share any other advanced feature here. So Vmotion, and then we selected Vmotion from here. That grayed out everything else, so this is only dedicated for Vmotion. And once we did that, so we click next. So either we get an IP from the DHCP that we have in server 1 machine, which is where we are, or we can go for static IP. So now what we can do is we can dedicate 10 and 11. So we already know that our machines are using did I give IPs there as well? Well, anyway, so 01, 02, 03, and 04, right? So we can just go for Vmotion. So Vmotion IPs used are, it could be 192.168.200.10 and 192.168.200.11. So when we go for fault tolerance on the same two servers, we can go for 12 and 13. Then we go for vSAN. vSAN actually requires 3 hypervisors. So in that case, we can go for 12 and 13 for the fault tolerance, so 14, 15, 16 for vSAN. So for now, it's 10 and 11 for IPs, or whichever IPs which are available that you want to give, you can give. Just keep an eye on that nobody else is using this. So I'm going to go for use static IPv4 settings, and then 192.168.200.10 and 255.255.255.0. Override default gateway. Now we do have a fake default gateway, which is the IP of this machine, which is 192.168.200.1. If suppose you don't want to use the 200.1 default gateway, then you can override it. Otherwise, you don't have to do this. So just the IP and subnet mask is enough on this VM kernel network adapter. So I'm going to click next. Okay, so it says that okay, so on this VM kernel adapter, you could have introduced more advanced features, but no, we're just dedicating it for Vmotion. So that's it for ESXi2 based Vmotion networking settings. So I'm going to click finish here. And so vSwitch 1 again got created. I'm just going to collapse it. And then vSwitch 0, I'll collapse that too. So vSwitch 0 and vSwitch 1 are here, and vSwitch 1 has VM Kernel Adapter Vmotion configured there with an IP. So that's the same thing we need to do with the next IP address on E6i3 as well. So I'm going to click E6i3. Okay, E6i3, well, same thing. So we're going to simply go for add networking here. So E6i3. Now there is under virtual switches, you can also see a Vm Kernel Adapter here, right? If I go back to E6i2, under virtual switches, there is Vm Kernel Adapter is also written there. If I click that Vm Kernel Adapters, so you can see that VMK0 is for management network, which is installed by default when host gets installed the first time, or the hypervisor or E6i gets installed the first time, while VMK1 is Vmotion and its IP is this. This is what we just installed now. So, and it just shows all the features, whatever was selected there. So that's the same view, and we can start add networking from there as well. The same thing that we started from virtual switches area. I'm going to go to E6i3 for the same view, which is E6i3 configure VM kernel adapters, and then here VMK0 is there, VMK1 is not there because we haven't created that yet. So add networking, when we click here, it's the exact same wizard that's going to start, which was there when we were on virtual switches, and add networking here. So let's go to VM Kernel Adapter, which is either you connect from there or click here, it's the same thing. I'm going to click here, add networking, just to show that it's the same wizard from here as well. And yes, we need to add VM Kernel Network Adapter, which will introduce networking side of this advanced feature, Vsphere V Motion. So yes, it is selected already. I'm going to click next. And so we're going to go for new standard switch here as well. And we're going for next. So we're going to add 2 network adapters because we added total 10 adapters here. We had total 10 adapters here as well, so plus. And Vm Nic 1 and 2. Remember that Vm Nic 2 and 3 we added back there in E6i2. So technically, suppose there you selected Vm Nic 2 and 3, and here you select Vm Nic 1 and 2, so it's okay, it will work. But for configuration consistency, we can also select, we can leave Vm Nic 1. In E6i2, we have given Vm Nic 1 to the VM switch 0, just for redundancy, right? So when we are creating here VM network or VM kernel adapter, so we can actually, just for for the sake of same configuration, we're going to go for 2 and 3, and Nic 1 we're not touching right now. Although you can select 8 and 9 as well, and it's going to work fine. Okay, so 2 and 3 are selected on E6i3 as well, just like in E6i2, and I'm going to press OK. Yes, they're both active, so load balancing will start, and click next. Well, we can just give the same name, so Vmotion. Okay, and VLAN ID, no problem. IP settings, IPv4, MTU, no change. TCP/IP stack, yes, we're going to dedicate this one Vmotion here, and now only Vmotion will work. Then click next, and then we have to give the static IP. Well, IP pops up here, I'll just change it to 11, and well, the subnet mask also pops up. Okay, well, then let's click next, and yeah, that's it. So let's go ahead and click finish. Now the VMK1 is at showing here, and it's 211 here. So this is the same view. If I want to say the same view here for E6i2, so I'm going to click on E6i2, and it's going to show the same view there with 210 IP there. So that's nice. Okay, so once this is done, I'm going to go back and check the checklist here. Yeah, so remove all switches, extra switches, yes, done. Let's create on vSwitch1 the Vm Kernel Adapter, done. Vm Kernel Adapter. And then make sure vSwitch 0 have 2 port groups, one for management and VM network. Yeah, we have that. Make sure our VM has an operating system 2012 or 2016 or 2019. Well, that would be better, but virtual machine migration, whether operating system is there or not, migration works and gets configured the same way. And it has VMware tools installed. Let's create a new data store on our shared LANs. Shared storage or LANs. We already have a data store configured. So let's move our VM with OS installed to this new data store. Okay. So basically we're done. Like we're ready to go for the migration. So all the checks are done, and what we can do is we can just try to go for all the 4 types of migrations that we talked about, and those are these. So one is the cold migration, then the suspended migration, then Vsphere V Motion, and standard Vmotion. Actually, it's going to be 4, not 5. So that's storage Vmotion. Yes, that we can separately do as well, but we're going to do cold, suspended Vmotion, and cross-host Vmotion. Cross-host would also include this storage Vmotion as well, right? So instead of doing a storage Vmotion separate, we're going to go for cross-host Vmotion that includes the storage Vmotion. So let's go for the cold migration first, and that does not really, it's powered off virtual machine, and it doesn't require any CPU or SAN even. So let's go for it. Okay, I'm here in E6i2, and there's VM1, and I'm going to right click on VM1 and go to edit settings. Okay, right click VM1 and go to edit settings. What I wanted to check is that if my CD, DVD have any ISO attached, it should not be attached. That's the first thing. Second thing, I intend to move my VM01 while it is off, but I need to check that which port group it is connected to. So first thing, CD, DVD, no ISO attached. Second thing, which port group it is connected to. It is connected to a port group that is attached on, that is on VS0. So it's okay, but it's on VS0. I was just thinking that if it's connected to a port group that we deleted the virtual switch off, so it should not be that case. So it's not. It's okay. Now I'm going to keep it at that, and I'll press O and K. So this is VM01. I didn't make any change there, and I'm going to right click on top of that VM01, which is off right now, and the destination is supposed to be E6i3, which is actually across the data center, right? So it's gonna give an extra message of that too, that hey, are you sure that you're going across data center, and are you sure it's the same network there as well? Just gonna ask that. So I'm gonna click migrate to the machine that is off. So change compute resource only. Yes, I don't want to move the files of the machine. I just want the machine itself to be registered to the other, which is also called moving. So change compute resource only and click next. And it shows actually all hosts there. And well, I'm trying not to touch the SXI01. Its CPU is also 24% consumed. And if I go to the right side, wow, memory is like 88% consumed. The rest are okay. And okay, so my destination, it's already on ESXi2 VM01. My destination is ESXi3. So I'm going to select ESXi3, and the compatibility has to be green. Otherwise it gives an error here that okay, there's this problem and that problem, that's why you can't go ahead. So I've defined the destination here, and then I'm going to click next. Okay, so here it says select networks and select destination networks for the virtual machine migration. There is migrate VM networking by selecting a new destination network. So, well, source network is sales PG VS0, and destination, destination does not have this port group. Destination is a ESXi3, which only has a VM network port group, this one, right? Yeah, it also says here compatibility that ESXi3 network interface network adapter 1 uses a network sales PG VS0, which is not accessible. So it says that virtual machine network adapter is actually connected to this on ESXi2. So if I go ahead, so that same named adapter is not there on ESXi3. That's what it's saying here. If I go to browse here, and there's only one VM network here on the destination ESXi3. So I'm just going to select that VM network. Well, it was just there as well. As soon as I select on the destination, so compatibility was just saying that port group by that name is not there in the destination ESXi3. So I selected the one that is there, and as soon as I selected that, so it says okay, we're okay. Compatibility just succeeded here as well. I'm gonna click next. Oh, there's advanced here, and advanced is just showing source network adapter VM01. So nothing. If I click basic, so just one less column. Okay, so let's go ahead and click next. Verify that the information is correct and click finish to start the migration. Okay, well, let's click finish. So what we're expecting is this machine to be landing here in ESXi3. It's done. So that was migration. Well, it's just powered off migration, right? So now what we need to do is, so the first migration was this. Yep.
Yeah, in my case, I am on a different port. So should I add my virtual machine or different that the port group which we made, the VM kernel?
Okay, again, so you have different port groups, which is okay.
Yeah. Does it matter?
No, it does not matter. As long as the destination port group exists, that's all you have to.
No, actually, see, I'm doing it from my ESSI server where I made the virtual machine. I had loaded Windows Server 2016 on that. And in that, basically, if I go to the edit settings, it is showing me the network as VM network.
Which is okay.
So which is okay?
Yep. And any port group it is on, it's okay as long as it's working and VM network is working. I know. The other one, destination, will only be VM network because that's the only one there in E6i3 if you're going to E6i3.
Okay, let me just try again. Next, VM network. It's giving me an error. It's saying virtual machines VM networks is the operation is being connected across data centers. This network may not be the same network on the same source and destination. This is because the network names are only unique within the data center.
Yeah, it's okay. It's a warning. It's a yellow one, right?
Yeah, yellow.
Okay, then it's okay. So
okay, next.
Yeah, then it's next finish.
Yep, it moved.
Cool. Okay, so now if we check our diagram here, so we have then suspended migration. So for suspended, we need to power on the virtual machine, and then we need to suspend it, and then we need to migrate it back from. So that's the same virtual machine that we can try, and it's on the E6i3. So on the E6i3, I'm going to go ahead and power on the machine, then I'll suspend it, and then I'll migrate it back from E6i3 to E6i2. So for that, I need to, I'm on E6i3. I'm going to click VM01, which I just migrated as powered off machine. I'll right click on it in E6i3 and go to power and powered on. So my machine does not have an operating system. It just powered on fine right away. And with or without an operating system, it's going to work the same. It would have been better if it was an operating system just to relate it to an actual environment, but it will work the same way. I'm going to right click.
Will you share my screen?
Oh, okay.
Yeah, just go ahead.
Yeah, the steps will be exactly the same, but yeah, we will know that, hey, there's an operating system inside as well. So how does it work that way? Actually, it's going to work exactly the same way.
Yes, I'm just logging onto my machine.
Okay. I have a wrong date and time on my machine. Okay, so here, yeah, so you can, if it's powered on, yeah, so, it's powering on?
Yes, powering on.
Okay. So once it is, powered on, then we can simply suspend it.
Are you starting? Okay, this is interesting.
Well, yeah, maybe it's deploying the Vmware tools, and okay, so
okay, we can suspend this now. All right.
Yeah, suspending would be okay. Okay, so all right. So once it is, oh, do you know how to? Did you suspend?
Yeah. You want me to unsuspend it?
No, suspend is okay, and it's gonna take time. Yeah, it's 8%, 9%. No, it's okay. Yeah, we want to suspend, and Vm01. Okay, give me a second. Okay, 45%. You're connecting site 2.
Okay. So this is suspended now.
Yeah. You just configured it on this side too?
Yeah. I just want to move this machine to ESS. I want to keep my VCSA without any virtual machines.
Okay, so before it was on E6i 1 and 3?
Yeah, it was the SSI1, which has my VCSA also.
Yeah.
So I moved it to 3 and I'll move it to.
Oh, now you want to involve 2 as well. Okay, 2 and 3.
Yeah,
Okay,
yeah.
that's good.
Yeah.
Okay. Yeah, so once we are on suspended, yeah, we can just do the same thing, and we can just right click on the migrate. And yeah, the same thing, the top one, change compute resource only. And our destination is ESXi 2. And next. Okay, so it says down there is the same thing. The virtual machine uses network, VM network, since the operation is being conducted across data centers. So obviously we're doing that across data centers. So it's saying that, are you sure that the network on the other data center accessible and the same or not? So yeah, we know that it's the same, so it's okay. And click next. Yeah, we're good. So finish. Oh,
Done.
that was fast. Okay, it's already done. So it's on ESXi2 already. Now, now we're gonna try to do the third one, which is the Vmotion, and for that particular, we need to have this machine powered on now. So let's power it on fully, and for that particular Vmotion, while the machine is powered on, for that we configured the whole thing, and so this. When the machine is fully powered on, then we're going to just simply move it, and yeah, it's okay. If it's just powered on, that's okay. And yeah, it's the same procedure. So let's start to right click on VM01 and go to migrate. And
Change storage. Change board.
well, for now it's change compute only.
Okay.
For now it's change compute only, and then compute resource only, and then next. And yeah, 3. No guest OS heartbeats are being received. Either the guest OS is not responding or VMware tools is not configured. Obviously, it was in the process of installation, so VMware tools are not configured. Okay, so we can ignore this warning and click next. And there are compatibility warnings here, which is okay. It's the same default port group on source and destination side, so it's okay. And next. And now this is the only new window there, and it just says you want to schedule Vmotion with high priority recommended or schedule normal Vmotion. So obviously it's going to be high priority, which means that more CPU and memory will be allocated to this particular Vmotion that is about to happen. So that, yeah, that's okay. And click next. Yeah, that's it. So we're going to click finish, and it's a powered on machine. If it moves from one to another, that's very good. And later DRS, when it is introduced, we're gonna use DRS as well for the automatic migration. 20%. 32. For the 7, for the 8. Okay, that was not that fast. But we're just moving the memory contents. Oh, hey, we did not use the storage, right? We did not, right?
Use the storage.
We did?
We did not.
Oh, did not, okay. Oh, cool, okay. So, we're good. Okay, so now the powered on machine moved, suspended machine moved or migrated, and powered off machine migrated successfully as well. Now we're going to go again from 3 to 2, but this time we're going to use the third option, which is to move the disk of the machine from one data store to another and move the virtual machine itself memory contents from one host to another. So we're going to go for, yeah, change both compute resource and storage. And next it's going to ask now which one, where do you want to go? Okay, select a compute resource. So where do it's saying, and yeah, that's great. It's inside 2. And then, yeah, next. And now it's asking your disk, where is it traveling? Oh, where was it before? Like, do you remember that, or? Oh, we can see it by canceling if we don't remember that. Yeah, cancel end. So on the right side, yeah, data stores, it's on 0. Okay. So yeah, we can go ahead. Now, do you know where is the E6IE, your VCSA storage? We need to avoid that. And, oh, it's also on 0. Okay, so it's good that we're taking it away. Although it's not a very big deal, it's just that, you know, keeping VCSA intact till the end of the course. So, yeah, we're going to move away from 0, this means, so that's good. So, yeah, we can right click again the VM01 and start the migration process again. And migrate, yeah, and the third one, and yeah, 2, and yeah, next. Now we're gonna go for 1, yeah, 1 is okay, or 2, anyone, yeah, we're good. And yeah, the network is okay, and yes, it is going across data centers, so it's no problem. And next, yeah, high priority schedule, which is okay, and finito. So now, first, actually it did not ask that which one you want to go first. It's just going for relocating a virtual machine first. So it's changing the hypervisors or hosts, then it's going to change the data stores as well. But it's not doing virtual machine migration plus storage migration at the same time. First it needs to finish host migration, virtual machine host switching, and then it's going to go for the storage of the virtual machine from one data store to another. Okay. that is just the virtual machine still moving, I guess, as per the recent tasks. Mhm. Yeah, it's gonna keep doing that. Although it could be that, in one process it might be showing the disk plus virtual machine moving instead of two processes. And if that's the case, that is gonna wait for the disk to reach, then it's gonna show us the progress, then it's gonna take longer time. Yeah, it's gonna take time. Wow. Yeah, it's moving the disk as well, I guess.
Yep, it's moving, but it's taking some time.
Yeah.
Let me set this activity on my main machine. Yep. Pretty slow, but yeah, it's doing.
Even just the moving of the memory contents was taking a little time, so the disk is like 10 GB now. It's on 35,
36, 36. It went up 1%.
Looks like that's all we're doing today, I guess. No. Well, we can actually discuss the next topic if you want. If everyone. this. Alright, so yeah, 37, yay! Woo! Okay, I'll pause the video. Resuming now, and yes, it is moved. And the storage, so we can just confirm, yeah, the data store is different now for that machine. It was 0 before, now it's on 1. And yeah, the storage, the host has also changed. So that's great, and that's what we wanted to go for in the Vmotion. Thank you for showing us with the operating system.
No problem.
Okay. Okay, so I'm just gonna connect back now to my machine here. Okay, so back to my machine here where the time was wrong and I set it to automatically be correct, but it did not do that. Oh, sorry. You know, sometimes very simple settings are additional data clocks. Am I kidding me? Regional is okay. Additional time. Additional. Okay, anyway, I'll just check it out. And so what we are going to go ahead for is if we go back to and check it out, our checklist, pretty much we have done all of these. So we did not just do this one, that the storage Vmotion was not separately done. Otherwise, we could have just selected the disk and we would have simply moved from one data store to another. So that's what it does. That it just asks that what is your destination data store. So that's what we showed in the two-in-one thing, Vmotion of virtual machine plus the storage of the virtual machine moving as well. Now, if we check our topic, so we have a much bigger topic, which is distributed virtual switch. And Vmotion, now guys, one thing that Vmotion must stay intact. Obviously, anything we configure must stay intact, but Vmotion must stay intact throughout the course because DRS would totally depend on the Vmotion to work, and DRS is a very critical feature. So throughout the, we're going to just make sure that nothing happens to the Vmotion configuration throughout the course, as some future configurations of services will need this. Now, the distributed switch, what is that and how it is configured? If we go ahead with the distributed virtual switch, so first of all, it is created on top of a vCenter, right? So it is, let me just do that. Really? I just opened a slide for that, but it didn't appear here for some reason. Oh, there you go. So distributed switch, a vSphere distributed switch acts as a single virtual switch across all associated hosts. This allows virtual machines to maintain consistent network configuration. Now, distributed switch is needed when you have a big environment or very big environment. Basically, you have like 1,000 hosts. We have just 3, right? You have 1,000 hosts. So if you have E6I hosts that many, obviously you imagine that how big the environment would be. I'm just gonna drag. I created a diagram previously. This one. Okay, so if I copy this, so if there's a big environment and that has suppose 1,000 hosts and 20,000 virtual machines, now you are told that, hey, can you change the networking of maybe, instead of in among 20,000 machines, can you change the networking of 5,000 virtual machines in one go? So that's gonna be difficult if you had to do this. And how do you do that? So suppose there are 20 VMs or 40 VMs per host here, and 40 VMs per host, or even more, 50, but there are 1,000 hosts, right? And there are 20,000 virtual machines. So you connect to, and you've been given a list of 5,000 virtual machines whose networking has to be changed. So suppose they need to be disconnected from one port group, and they need to be connected to another port group. In that case, you would remotely connect to first hypervisor and go through the virtual machines and change the networking. Then connect to the second hypervisor, then third one, then fourth one. Like from the distributed switch, you're gonna click first hypervisor, then the second one, then the third one, then the fourth one, and go to the virtual machines and change the networking. So for that particular purpose, where you want consistent and also persistent configurations, network configurations on all virtual machines. Suppose there are 20,000 virtual machines and you want to change all 20,000 virtual machines port group to another port group. So you can do that in one go from distributed switch. And so that's the first thing, or that's the main purpose of a distributed switch, that can you really change the networking of or virtual machines, or you want to handle the networking of virtual machines. Like a virtual switch, a distributed virtual switch is a network hub for virtual machines. So yeah, for virtual machines, it's just a switch. A vSphere distributed switch can route traffic internally between virtual machines or link to an external network. So, well, there's so many features for distributed switch, but basically you're controlling on large scale the networking of virtual machines. A vSphere distributed switch can have multiple distributed port groups assigned to it. Virtual standard switch has virtual port groups. Virtual distributed switch have distributed port groups. So distributed word comes before the port groups. And from the perspective of VMs, the VDS or virtual distributed switch is the same as virtual standard switch. VMs, for them, VSS or VDS, I don't know. They just connect the same way to both. And there is identify vSphere distributed switch VDS capability. So VDS or virtual distributed switch acts as a single virtual switch centrally managed across all hosts through vCenter. So you install it on a vCenter. And okay, let me just put that here.
So it could go across
The ESXi2 and the 3?
Oh yes, or ESXi 4, 5, 10, 20, 100, 300, 500. Every ESXi can be connected to a distributed switch. And in one go, we can make changes on the configurations. Well, we're gonna check that out, how it is really done. So VDS offers a reduction in management and complexity. Obviously, if you have to handle the networking of 1,000 E6I hosts and 20,000 virtual machines, or 30 or 40,000 virtual machines, then this would be a blessing. If it's that large company, obviously they can afford the expensive license of distributed switch, because distributed switch also is available with the most expensive license, highest one, Enterprise Plus. And DRS and distributed switch, these two features are available with Enterprise Plus only. Now VDS is also known as DV switch, so virtual distributed switch or distributed virtual switch, whichever way you want to say it, and has DV port groups and DV ports. So VM kernel ports can be called DV ports, and DV port groups are just virtual port groups. Separation of data and control planes. So option to customize the third-party switches like the Cisco Nexus 1000V. Now you may or may not have used the Cisco. You may have used Cisco physical switches. So Cisco sees that everything is virtualized and now everything is cloud as well. So they have to come up with their software versions of their switches and routers. This one is Cisco Nexus 1000V. That is actually you get it if you are a Cisco partner, if your company is a Cisco partner. First thing. Second thing is you can just put it as an appliance. So it's a virtual machine with a switch software or a router software inside, and you can connect this, you can add network cards to this machine and then connect it to different other virtual machines. The data can go through this virtual machine's network cards to outside. So it acts as a router inside, but it's a software. So distributed switch connects and it's compatible with Cisco Nexus 1000V, and only available in Enterprise Plus. Okay. And other than that, there's identify vSphere distributed switch VDS capabilities, total virtual network switch ports per host, VDS and VSS ports. Total, if you include virtual distributed switch that it can support, and the virtual standard switch ports is 4096. Maximum active ports per host that VDS and VSS can support. Active means virtual machines are connected, so there are 1016. Static dynamic port groups per distributed switch, 10,000 ports a distributed switch can connect. And how many distributed switch you can create? Distributed switches per vCenter you can create 128. We're gonna create one, and that's gonna be complex enough. So you can create 128 distributed switches. Now suppose you have 40,000 virtual machines, right? 40,000. So you would need 4 distributed switches for that, or 4, right? Ports per distributed switch, 60,000 actually it can support. 60,000. So yeah, your 45,000 actually is covered. So, but you can create more than one distributed switch on your vCenter, and as we're going to see that one is enough for us the way it is configured. So distributed switches per host. So one distributed switch can connect to or one host, distributed switches per host. So it's 16 distributed switches one host can connect to. One host can connect to 16 distributed switches maximum, and you can create maximum 128 of those. So that's just the maximums of the whole environment. If we go ahead, recap what is a standard switch. Actually, we don't need to read that. We already know. We just talked about standard switches there. What is vSphere distributed switch architecture? Networking with vSphere distributed switches is driven from the data center level. So the first difference between standard and distributed switches: virtual standard switch is inside a host. Distributed switch lives inside a vCenter, right? So that's the first difference. And a vSphere distributed switch exists as an object on the data center that acts as a virtual switch across all associated hosts, enabling virtual machines to keep consistent network configuration as they migrate across hosts. So I'm going to explain now in diagram what it says. Uplinks connect the vSphere distributed switch to physical network adapters on associated hosts. This is what we need to learn, understand in the diagram. Each host can connect one free physical network adapter to a vSphere distributed switch for each uplink port on the vSphere distributed switch. Seriously? Okay. So let's talk in English now. Okay, so here, this is also obviously going to be confusing. Maybe I can just create that again. So you have one vCenter here, and that vCenter, you decided to create a distributed switch on top of that. Distributed switch normally has uplinks. Uplinks are just connection to another switch, right? Or another next hop. So uplink 1, uplink 2, uplink 3 and 4 and 5 and 6 and 20, 30, 80, how many uplink you want. You can have those. So a distributed switch lives on top of a data of a vCenter. Now that's now if you have hosts here, and I'm creating hosts in this way because the connectivity I need to show. Excuse me. And all hosts have network cards here. So uplink 1 and 2 are there already. So how about 2 NICs here. I can pull this off. No, right? Not fit. Okay, anyway, so I just wanted to, I was feeling lazy, so okay, these are network cards here, right? And what happens is that the network cards, physical NICs here, needs to be. So what is the current infrastructure here? What is the current architecture? Sorry, they are all connected to their standard switches. The local physical NICs are connected. So this is your local VSS, 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 VSS. Now you have those connections right now going through this guy, and but now you need to actually connect them, the hosts, to the distributed switch. So how the distributed switch controls or basically communicates with a host. Distributed switch will need to connect its uplink 1 to one network adapter, physical adapter of each host. Again, uplink 1 connects to one network adapter, one free network adapter of each host. So uplink 1 connecting to one free network adapter of this host. Uplink 1 is connected to one free network adapter of this host, and so on. And through this uplink 1, now this is like a network connection, network card connection, and you want redundancy in this. You want actually 2 connections. Or if I lose a connection from the whole distributed switch through this network card goes down. So how about if I keep 2 uplinks through this uplink also? I'm going to make a connection to another free network adapter. So okay, I'll have to should have created 3. 1, 2, 3, 4. Okay. So you say that, yeah, I'm connected to each host through one uplink. How about redundancy purpose? I'll just connect my other uplink to another free network card of each host. So that will be my So distributed switch can connect in with two uplinks to each host. So when we connect the distributed switch, which is living inside the vCenter, to each host through their free network cards, then the features that were available and were being handled by VSS, like VSS is handling what? VSS is handling port group, which is doing what? VM communication. VMs are talking to each other and to the outside world. VM network communication. So VSS is handling that. Virtual Standard Switch till now is handling that network communication. And then there is Vm Kernel port, and first is management network. So vSwitch 0 of each host is handling management network VM Kernel Adapter, which is the main task of that is to let us remotely connect to that particular hypervisor and manage it. And then now we just created another VM kernel port, and that is handling vMotion now. So Virtual Standard Switch is responsible for these three tasks on, suppose, all hypervisors here. In our case, just the two, E6i2 and E6i3. So what happens here is when you introduce the distributed switch, then you can actually migrate the tasks away from Virtual Standard Switch to distributed switch, which means that anything to do with remote connectivity, suppose this is a very sensitive task or feature here, that you're remotely connecting. vCenter is remotely connecting thanks to vCenter is remotely connecting thanks to this service. From within the vCenter, we are able to see E6i 1, 2, 3 because of this service. How about we tell VSS, hey VSS, thank you till now, you've been doing best job there, but we are about to migrate this away from you to the distributed switch. This task, we're going to also migrate away another crucial service that is called VM network communication, or the port groups. So from now on, all the virtual machine networking through port groups. So all virtual machines will not be using the port group of the VSS. Thank you VSS for doing that till now, but we don't need your service here as well. So we're gonna migrate away the port virtual machines networking or their connectivity to the VSS port group. We're gonna migrate away to the distributed port groups now. So all virtual machines, they need to talk to each other and to the outside world has to do that with the help of distributed switches, distributed port groups. Instead of virtual standard switch port group, virtual machines will now be using distributed port groups. And how they are able to do that, because distributed switch is connected through their uplink to one free network card of each host, and from there they're communicating and they're telling the virtual machines, or they're controlling the virtual machines networking. Well, it's not that easy to understand right now, but the basic structure, that how distributed switch gets connected to each host and what we can do after connecting, and what we can do is we can move away these critical services that were being handled by a virtual standard switch. We can migrate away those services from virtual standard switch to the distributed switch. So first thing what we're going to do is how to install distributed switch, then how to move away or migrate these features from the host to the distributed switch. And third thing is that we're not going to actually go for moving all the features. I want to show you one more thing. vCenter based distributed switch can work with virtual standard switch. Like these two switches can work together as well. How? We're not going to migrate Vmotion service. Vmotion service will stay on the virtual standard switch, management network, very critical or sensitive service that without this service, we can't actually remotely connect to a host and manage it. So we're going to move away this service to distributed switch. And obviously another critical one, how virtual machines can talk to each other over the network and to the outside world. So we're going to move away port group from virtual standard switch to distributed switch. And but we're not going to move Vmotion just to prove that virtual standard switch and distributed switch can work together as well. And what will be the proof that it all worked? Suppose we have done that, we moved away the management network service from virtual standard switch to the distributed switch. So what the proof of that it works is that as soon as you move or migrate successfully this service to distributed switch, do we still have connectivity to all our hypervisors? Because that's what it's doing. Remote manage. Can we still remotely manage the hypervisors? So that will be the first proof that yes, the migration of management network Vm kernel port from virtual standard switch to the distributed switch is successful. Then second thing is port group. We're going to move this service from local switch to the distributed switch, and we're going to not move the Vmotion. It's going to stay here. So overall, then we're going to do a Vmotion. We're going to move a virtual machine. We're going to migrate a virtual machine from one host to another to check, because it heavily relies on the networking, correct networking. If there's slight error in the networking, Vmotion cannot happen, right? So once we are done with moving two critical services to the distributed switch and one critical service remains here, after that at the end, we're going to do a migration of a virtual machine from one host to another and back as well, just to check that if networking is okay, it's going to Vmotion. If networking has some issue, it's not going to Vmotion. It's going to give you error. So obviously it's a sensitive task to move very critical services from networking services from standard switch to a distributed switch. So any slight mistake might break the communication or connectivity. So this is what we.
What's the advantage of doing that? What's the advantage of doing this?
Advantage is that if we move the port group from standard switch to the distributed switch, then suppose, as we were saying before, we have 30,000 virtual machines there. So you want to change their port groups from distributed switch.
Okay.
You can change it from one distributed port group to another distributed port group. So in one wizard, you can select all 30,000 machines.
I get it.
Okay.
Yep.
Cool. So, and that's management network also. Mainly it is, the benefit is here in the persistent virtual machine networking, but whatever service you want, if it's a very big environment, then introducing a distributed switch makes perfect sense. If it's a medium environment, small environment, oh, Hugo says power loss. No power loss.
If you were doing this process in the middle and you lose power, that's it.
Oh.
Is that correct?
Sorry, I was saying that you had a power loss and then you joined us back in the class. So. Okay.
No, I was talking about doing that choice. The migration over with the distributed switch, and you would suffer a power loss, right? Or that would happen. Then that would essentially break.
Yeah. If
is another example.
Yes. If during the migration, so we should, in a production environment, I would take a backup of the configuration here and backup of the whole configuration of all the hosts, and then I will try to move. But during that, if power loss is there, yes, it's our really bad luck. Normally we should have UPSs there, uninterrupted power supply, backup power. It should just switch right away. Otherwise, yes, it's gonna be affected. As long as we have the backup, we can just restore the distributed switch setting and especially the standard switch setting, and we should be okay. But power loss will break it, definitely break the migration process. But will it, really misconfigure the standard switch configuration? No, it won't. The process of moving will be affected, and we can actually start the process. But still, we don't know. It could be there could be conflicts there. So yes, taking backups and then doing it would be the best idea. But definitely, it will break it. So break the configurations. So what we're trying to say here is, if I go back to the slide, that the uplinks connect the Vsphere distributed switch to physical network adapters on associated hosts. So because of the distributed switch uplinks, you can the distributed switch can talk to every host. It needs to connect to one free network adapter of every host that you want distributed switch to manage remotely. And each host can connect one free physical network adapter to a vSphere distributed switch for each uplink port. So one uplink, one physical adapter. That's what we saw in the diagram as well. And if we go ahead, virtual machines NICs connect to vSphere distributed switches through distributed port groups, which aggregate multiple ports under a common configuration and provide a stable anchor point for virtual machines connecting to a labeled network. Whew, okay, what does that mean? So the thing is that virtual machines are connecting, those virtual machines are connecting through the network cards to that. Now, again, they cannot see the network cards directly. They will be able to see the distributed port groups. Now, as soon as the distributed switch connects to the network card, the distributed port groups will be visible to virtual machines on each host as well. So first step is always, after distributed switch creation, we need to make a connection to each host. Once the connection to each host is done, then whatever configuration you do here will show up to virtual machines as well, and that's how they will make that connection to the distributed port group instead of virtual standard switch port groups. Obviously, when we do it, we get to know a little more about it. But this is overall concept about distributed switch. And if we go ahead now, guys, obviously there's no time for lab now, and next week I will have to pretty much do an explanation again, because in 1 week we would have forgotten it. So some of this concept I will have to repeat next week as well, obviously.
Can you share the PPT?
Oh yeah, sure.
Yeah, thanks.
So guys, this is there are some more advanced features that we need to discuss, but I will have to discuss that again next week as well, right? So I'll share that PowerPoint slide, and then we can connect next week, and then we can first of all again discuss all these options, and then especially the diagram, and go ahead for the lab. So next week we'll be going for the distributed switch and then cluster, and in the cluster we'll go for HA and DRS. So those are very critical features. So okay, so that's not much time, and I have to repeat anyway all this again, or much of it again. So I'll just upload this slide now, and see you next week then. All right, welcome. Thank you. I'll just upload this now.